Hey guys, welcome back to chapter 14. In this video, we are going to do one last example about how a pH of a buffer changes. But this time we're going to look at the addition of a base instead of an acid. So here's our example. What is the pH of a 1 liter buffer that has 0.65 moles of acetic acid and 0.57 moles of sodium acetate? That has 0.01 moles of sodium hydroxide added to it. The Ka for acetic acid is 1.8 times 10 to the negative 5. Go ahead and pause the video, see if you can work it out. I'll catch up to you on the other side. So step 1 is to write a balanced equation for the buffer. Step 2 is to write the equation for the addition of, in this case, the base. So our acetic acid buffer is back here. HC2H3O2 that always reacts or is in the presence of water. And this is our acid. That is going to donate a proton, C2H3O2, and then water acts as a base, accepting that proton. So our conjugate base is that acetate ion. In this example, what we are adding is sodium hydroxide. And that is a strong base. So opposites attract. That strong base is going to be neutralized by our acid in the buffer. It is going to completely be neutralized. So what will be left from sodium hydroxide will be the sodium ion. So this dissociates into sodium and hydroxide. Sodium will spectate. This hydroxide acts as a base or a proton acceptor. So we'll get water. And then our acid is our proton donor. And we're left with that acetate ion. Alright, so now we just need to draw our table to depict or to quantify this process. So we've got sodium hydroxide, acetic acid, and the acetate ion. We've got before, added, after. So before we add our strong base, we don't have any of it. Reading back through our problem, we've got 0.65 acetic acid. And we start with 0.57 of the acetate. We are not going to add any of our weak acid or conjugate base. We are going to add our strong base, which is 0.01. After it has been neutralized, so after this has happened, there's going to be none of that left. We are going to use our weak acid, and we are going to create more of our conjugate base. So once this is all said and done, we're going to have 0.64 of our acetic acid and 0.58 of our acetate ion. Now we plug this into the Henderson-Hasselbalch equation to get the pH. So pKa is negative log of the Ka, which is 1.8 times 10 to the negative fifth, plus the log of our base over our acid. So our base in this case is 0.58. Acid is the 0.64. Cleaning this up a little bit. So I'm going to take the negative log of 1.8 times 10 to the negative fifth. I get 4.74 plus 0.58 divided by 0.64. I get the log of 0.9. So we get 4.74 plus, we take the log of 0.91, which is negative 0.04. So the pH is 4.74 minus 0.04 equals 4.7. So that is how does the pH change of a buffer when we add a strong base. I hope you guys found this helpful.